This lesson will be on solving mixture problems. The essential question for this lesson will be, how do you solve math word problems involving mixtures or percent? So let's start by discussing what do we mean by a mixture problem. Well, let's look at an example here. Let's say I've got a 5-gallon container, and inside this 5-gallon container I have a mixture of water and vinegar. Okay? And let's say that I have 2 gallons of vinegar and 3 gallons of water. Now, let's say I have another 5-gallon container which also has a mixture of vinegar and water, and let's say in this container I have 1 gallon of vinegar and 4 gallons of water. Now if I combine these two containers together into a larger 10-gallon container, what will I have? Well, let's see. So let's assume we have this larger 10-gallon container. And obviously we will have 10 gallons in this, but how many gallons of vinegar are we going to have? We're going to have 3 gallons of vinegar and 7 gallons of water. So you might say that we had a mixture initially that was 2/5 or 40% vinegar, and we had a second mixture which was 1/5 or 20% vinegar. We combined these two and we ended up with a mixture which was 3/10 or 30% vinegar. Okay, so this is what we mean by a mixture problem. Now, let's take this information and put it into a table. Okay, so rather than drawing a picture of 3 containers, let's put this all into a table. Okay, so I've got a table here with 9 blocks in it. The top row is going to represent mixture number 1. That's this one in the upper left here. So this is going to be mixture number 1. The second row is going to be mixture number 2. And the third row is the total when we combine the two. All right. Now, this first column is going to represent the total amount of liquid, okay? So that's the amount of liquid we've got. The second column is going to represent the percent vinegar, okay? And then the third column is going to represent the amount of vinegar, okay? All right, so mixture number 1, we have a total amount of 5 gallons. We have 2 gallons, that's vinegar, so 2/5 or 40% is the amount of vinegar in the first mixture. The second mixture also has 5 gallons. But it has only 1 gallon of vinegar, and the percent is 1/5 or 20%. Now, obviously, as we go across the row, if we change the percent to a decimal, it's got 5 times 0.4 is going to equal 2. The second row will be 5 times 0.2 is going to equal 1. Now the bottom row is the combined, when you combine these two. In this case, we've got 10 gallons total. We now have 3 gallons of vinegar, or 30%. And you can see that if we multiply 10 times the decimal equivalent of 30%, we'll get 3. And so here in a table is the same thing we had when I showed the picture of the 3 different containers. Now, if you look across, as I say, looking across each row, you're multiplying. 5 times 0.4 is equal to 2. 5 times 0.2 is equal to 1. 10 times 0.3 is equal to 3. Vertically, you're adding. The amount here is obviously, you've got 2 containers of 5 gallons each. So if you add the 5 and 5, you're going to get 10. If you add the 2 and 1 vinegar, you're going to get 3. The percent is not an addition, but it's basically based on a calculation of these, the amount and the vinegar amounts. So now let's look at an actual problem, because normally in word problems you're not going to be able to fill in this entire table of 9 boxes. You're going to have some things that are left unknown and you're going to have to calculate them. So let's look at an example. Alright, the example I'm going to use is one that was on the worksheet we had in class, and this is the one which read, 7 cubic meters of soil containing 50% sand was mixed into 3 cubic meters of soil containing 20% sand. What is the sand content of the mixture? Alright, so let's start off with the table, just like I had before. The first row is going to be the first mixture of soil. The second is going to be the second mixture of soil, and then on the bottom, the third row is going to be the total when we've mixed the two together. First column will be the total amount of soil that we're talking about for each of these. The second will be the percent that will be sand, and then the third is going to be the amount of sand. Okay, so let's start with the first one. We've got 7 cubic meters of soil, and it's 50% sand. The second is 3 cubic meters of soil, and this is 20% sand. And we want to know what is the sand content of the mixture. Okay? So what we are looking for is actually the percent of sand in the final total mixture. So this is going to be our variable, and we're going to call it x. All right, well, let's look across the top. If I've got 7 cubic meters and it's 50% sand, how much sand is in the first mixture? Well, 0.5 times 7 is going to be 3.5 cubic meters of sand. Okay? The second mixture is 20% sand, but it's only 3 cubic meters. So it's 3 times 0.2, or 0.6 cubic meters of sand. Well, what's our total mixture? Well, our total mixture, if we add up the soil here, is 10 cubic meters. The amount of sand in this 10 cubic meters, if we add the 3.5 and the 0.6, comes out to be 4.1 cubic meters of sand. Now the only thing remaining is to determine our unknown, which is x, which is our percent. Well, percent is going to equal the amount of sand divided by the total mixture. So we're looking for the amount of sand, which is 4.1, divided by the total, which will be 10. So this will give us the decimal equivalent of the percent of how much of this final mixture is sand. So let's take, if we take 4.1 and we divide that by 10, what do we get? We get 0 0.41. And remember, right now we're solving for x. Well, if you get 0.41, that's the decimal. If I convert that to a percent, my final answer for this problem is the final mixture contains 41% sand. So all mixture problems can be done the same way with this 9 square box, where the top row is the first mixture, the next row is the second mixture, and then this is the total mixture. First column is the total amount of substance. The second column is the percent, and then the last column will be the percent times the total, which will give you the amount of that particular item in that particular mixture. Now, hopefully this helps to explain mixture problems a little better. So study this video, and we will do some more mixture problems when you come to class next time.